Hello all. Alright, admittedly it's been longer than 12 hours, but I think you're going to appreciate why I left it so long when I show you the results of our experiment. Now, if you didn't watch the video last time, you can go back and have a little look at it now. But we put into a jar 2 normal chicken eggs, and we filled that jar with white vinegar. What we were hoping to see is a reaction between the acid in the vinegar and the calcium carbonate, which is an alkali in the shell of the egg. Let's see what happened. We now have 2 inflated eggs that are now very, very soft. Now, before I show you the eggs themselves, what I wanted to show you was the residue all in the bottom of the jar. Now, as you can see here, bits of the shell have broken and settled into the bottom. Now, some of this will be bits of calcium carbonate that aren't able to dissolve because the solution is saturated. But some of it is other compounds that you found in the eggshell itself. And those things have just settled on the bottom with the vinegar. Now, let's get the eggs out themselves and see what's happened. So, what I have now is some standard kitchen roll. You could use a tea towel here, but I just don't want to get vinegar all over my sides. And I'm sure if you are doing this at home, your parents will appreciate that also. I'm now going to remove the egg from the jar. Now here, you can see there's still quite a bit of liquid in there. So if you would rather use a spoon or use some gloves, then you're more than welcome to. I, however, am a bit of a fan of just getting stuck in. Please remember, though, that if you do get the acid, which is the vinegar, on your hands, please wash them afterwards. It is only white vinegar. It isn't terribly hazardous, but you don't really want that on your hands if you're then going to eat, etc. So I'm going to take out one of these eggs, and ugh, year 7, they feel so weird. So let's take out an egg and show you what it's like. So first of all I'm going to do is I'm just going to pat it down very, very gently to remove the excess vinegar from it. Now, the reason I'm being so gentle is because this egg is still raw, ladies and gents. And if you do this experiment at home, then you'll be able to see that. Now, I'm going to hold the egg closer to the camera for you. Now, this little bit of white on the edge here is just a little bit of unreacted calcium carbonate. Now, ideally, I would have been able to replace my vinegar halfway through because it actually loses some of its strength as it reacts with the acid because it becomes neutralized. Now, hopefully this doesn't end badly, but what you can see now is I have an egg which is no longer got a shell on it. But normally, when you have an egg with no shell, you're left with just the contents of the egg, the runniness inside. Now what I have is a squidgy, bouncy egg. Now, the reason this has happened is the acid and the alkali, the vinegar and the calcium carbonate have reacted, and what you formed is a soluble salt, which is now left in your jar. That means it's no longer coating the outside of your egg. And so you have got this egg that has got no shell on it, but it's still got a membrane. Now, this membrane is intact because it does not react with the acid in the same way that the calcium carbonate does. I can't tell you, year 7, how strange this is. Now, I've heard that these are bouncy, so let's just see. And I am slightly concerned it's going to end in tears, but we'll see what happens. I'm going to bounce it from a low height first of all. Oh, it is. Oh, that's gross. So let's try a bit higher. Now, it's quite intact still. Now, like I say, guys, that is a raw egg inside. Now, I've got 2 because there is something else I would like to... Now, yes, I was just going to say to you, I've got 2 because there is something else I'd like to do with it. But as you can see, I've managed to pop the egg in here and have managed to isolate the remains of the membrane, which is quite cool in itself, to be honest with you guys. So this is what's left over. I'm going to put that back in there and I'll deal with that off camera because that's gross. But you can see, guys, can't you, that I didn't cook the egg. I haven't cheated at all. This is what's inside the raw egg that we started with. Only now what we have is an egg with no shell. We've got a squidgy membrane still intact. It's runny on the inside. If you had this in your hand at home, you would feel that. It bounces. And what's happened here is it's increased in size. Now, the reason that one probably popped is because what's happened is as I've left it not a long time, the egg has actually started to absorb some of the water from the vinegar around it. And that's meant that it's increased in weight. Now, one way that I could see what happens with this now is I could pop this into a saltwater solution. So that's my challenge for you, Year 7. What would happen if I put this in some salty water and left it for a few days? What would happen? Now, I'm not going to do that because I'm slightly concerned it's going to break again, but it would be really interesting to see your results if you could. Now, hold on with me for a second because now I'm going to show you exactly what science has just taken place.
So Year 7, what has actually happened? Well, we began with an egg. We added some white vinegar and I left mine for about 3 days. Now what we made was a bit of a weird squidgy egg thing, but you know that's not science, so let's figure out exactly what happened. Well, in our egg, we had something called calcium carbonate. And calcium carbonate is an alkali. And that's why I have drawn this purple cloud around it. Because hopefully you can remember that when we add universal indicator to an alkali, we get a purple solution. I then added it to vinegar. And vinegar has a couple of different acids in there. But the one that you find predominantly is an acid called ethanoic acid. Now, ethanoic acid is a weak acid. That means it's not going to be corrosive, it's not going to burn. It holds on to its hydrogens a lot more tightly than a strong acid would, such as hydrochloric acid. That means I've popped a little yellow cloud around there rather than a red or a pink one because it's only a weak acid. Now, what do we make? Well, I told you earlier on in the video that we make a soluble salt. And in this case, we have made calcium ethanoate. And calcium ethanoate is a neutral salt. And it dissolves in the liquid, which is why you couldn't see it at the bottom of the jar. Well, you could see some stuff, but you couldn't see all of it. It's also why it left the surface of the egg. We also made water, because water is always a product when you react acids and alkalis. And lastly, hopefully you're thinking, but miss, we saw bubbles coming off of our egg when we first added the acid. You're absolutely right, we did make something else. We made a gas, and that gas was carbon dioxide. And carbon dioxide, we know, has the formula CO2, and that 2 is littler. So this is the neutralisation reaction that took place when you added your egg to vinegar. And that's the end of that practical Year 7. Remember my challenge for you. Can you add your now squidgy egg to a solution of salt water and leave for a while? What happens? Does it increase in mass? Does it decrease? Can you think about why that might be? Next time, I'm going to take you through a chromatography practical that we can do using household items. Keep well, everyone, and I'll see you again soon.